So I am back with another sorting technique. It is called merge sort. So before merge sort, we have to know how to merge two sorted arrays. Okay. So that is the first step towards the merge sort. So before doing merge sort, we have to know how to merge two sorted array. Okay. We'll come to this, like how this goes to this merge sort. So first we'll learn this merge to sorted array problem. Okay, so how we will go on to do this one. So what we can do is, see, so first we will have two arrays, right? So for both the arrays we can take its length, right? So we can get the length of the both the arrays, right? So okay, so what we will do, okay, so see here, you can see for num1 the length of the array is 3, and for this one, for num2, the length of the array is 4. So here what we can do is, see, so we can go through both the arrays, right? So we can take two pointers. One pointer will be going to the length of num1. So here we can take one variable for this one, right? So okay, so L1 we can take length 1, we can take 3, and L2 we can take 4. What we can do, we can run one while loop, right? So while, so let's take two pointers, one I and j, both starting from 0 0, while, right, while I is less than L1, so I will go through all these elements, and j is less than L2. Okay, so j will go through all these elements, but see here we are using AND, right? AND operator. So while this is true, like smaller array, while we are traversing, till then only it will run. Whenever this condition gets false, this one automatically gets false. So if num1 has 3 elements, so j will also stop at this element, right? Because this one has stopped at this element, only 3 traversing it has done, 3 elements traversing it has done. So num2 will also stop, j will also stop at num2's third element. Okay, so but now what we can do, we can check. So if this nums1 of I, this 0th element, and j's 0th element, like num2's 0th element, which one is bigger, we can check. So let's say we have taken one result variable, result. So result is an empty array. Okay, now what we will do, we can check, like nums1 of I, if, okay, if nums1 of I is less than or equals to nums2 of I, nums2 of j, sorry, then what we can do, we can directly put this one in the result, right? Result dot append nums1 of I, we can put it there, right? Okay, so here what we have got, this 2 we have got, right? 2 we have got. So now we can increment. I can point to 5 now. 2 is already processed. So what we can do here, we can do I plus equals to 1. Okay, if this is not the case, so here one thing you should see here, nums less than and equals to I am using. So if there is some equal elements also, then what we can do, we can put any one of this one, right? So let's say we are putting the nums ones element in that case. Okay, now the else case, what will be the else case? So this nums 2, this one is smaller. Let's say we have one first element as 1, then what we would have done, we would have put 1 here, right? We would not have put 2, we would have put 1. So now it is not the case. So what we will do at that case, we'll do result dot append nums2 of j. Now increment j. Okay, so let's say we have done that. So I is equals to 2. So I is equal, when I is equals to 2, because L1 is 3, it will stop. So here also in j also this will stop after 3. So this 3 element got processed. So when it will get processed, what will be the output till then? It will be 2, after that 4 will come. So after that, here I was here, right? I have told you I was here and j was still there, still here. Okay, j was still here. So then 4 came because of this condition. Okay, now j will increment, right? So okay, j we are incrementing to here. So now I and j again it will compare. Now it sees nums1 of I, that means 5 is less than nums2 then 6. So result of append this one, 5, smaller one. Okay, we are putting 5. Okay, now just increment I. Okay, now it is in 7, j is in 6. Now which condition will be true? Yes, you are right, this condition will be true. So nums2 of j, what is this? Is 6. This one we should include it here, right? Okay, now this j we are incrementing, it is in 8. Now again we will see I is 7, j is 8, nums2 of j is 8. So which one will include here? Will include 7, right? Now after that 7, it is 7. Okay, now we are incrementing this one. Okay, we are incrementing this one. Then what we will get? It is 3. Then it is already processed. This one is already processed. Then this loop will stop. Now what we will do? We will just do later part. So now we'll check one for loop. Okay, so for loop also we can check with while loop also. Okay, while loop only we will use. While j is less than L2, we'll just put all the remaining elements here. Okay, result dot append all the remaining elements, means nums2 of j. then what we have to do, we have to increment the j counter. But there is another case. Let's say this one was bigger and this one was smaller in length, then there could be left out elements for this nums one, so we'll check that also. So while I is less than L1, that means some elements are still there to be processed. So what we'll do, result dot append nums one of I. Now I plus equals to 1. So this is the whole code for this one, right? So now what will happen, this 8 and 9 is there. Here this is already false only, so it won't go inside this one because I is already greater than I is already equals to length, but here we are saying it is less than length. So now here this 8 and 9, it will process, j is here, so it is true, this condition is true. So here we'll put 8 and 9. When it is 9, it is equals to the length of 4, it will be equals to the length of 4, so it will be false. So we get the merged sorted array. Right, now we'll go to the merge sort. Okay, in implementation of the same algorithm, merge to sorted array, there is two sorted array, nums1 and nums2. Then we have to return one sorted array. We have to merge this both in a sorted manner. Okay, so I and j, like I have explained, we are taking 0 and 0. Then result, we are initializing with one empty array. Then while I is less than L1, j is less than L2, we are appending, if nums1 is less than nums2 of j, then we are appending nums1 of I, and I we are incrementing, else we are incrementing j and putting nums2 of j. So it is like I have explained just now. This is the clean code of this one. So let's check now with this input. This is sorted and this one is also sorted. Okay, yeah, see, 2 3 5 2 3 5 6 7 8 9 6 7 8 9. Yeah, so this is the first step for the merge sort algorithm. Okay, what is the time complexity of this one? You have seen, right? So this is nums of, so this is list, whole list nums1 we are iterating and whole nums2 we are iterating. So it will be O of n, right? It is O of n. The time complexity will be O of n, big O of n, because all the elements we are traversing through this nums1 and nums2. And the space complexity, we are using extra space, and here we are putting total nums1 plus nums2 elements, so that is also goes to O of n only. Big O of n. Okay, next we will check how do we implement merge sort with this implementation. Thank you.